Welcome to Lesson 94. We're going to talk about uniform motion problems, and we're going to talk about them in an addition sort of mode. Up until now, we've been talking about the distance of one equaling the distance of another, or a second. But now we're going to talk about adding two different distances together to find a total. So now our problems are going to look like, those are what we call equal distance problems. These are uniform motion with a sum of a distance. So this time we're going to be distance 1 plus whatever distance 2 is going to be equal to some number. So we're going to have a total, and we're going to have to suss out or calculate the missing information, just like we would in any other algebra problem. We're going to be given 3 of the 4 elements because we know that distance is rate times time, right? So the rate of one times the time of one plus the rate of another times the time of another would still give us that same total distance, right? So if you have 3 of these pieces of information, you should be able to find the 4th through process of multiplication, division, subtraction, using all of the 4 basic operations that we have been using since elementary. So let's put those into practice and see what we can do with problem 94.1. And I'm going to walk you through it so that you can see how it all flows together. So here we have 94.1, and we're going to talk about some buses. So here we have a southbound bus left Fort Walton Beach. So this is the starting point. This is Fort Walton Beach, which I hear is a great place to go on spring break or to visit in the summer. So this bus left Fort Walton Beach, and he is the southbound train. I'm sorry, the southbound bus. And he left at 9 a.m. So he left Fort Walton Beach at 9 a.m. And then 2 hours later, this bus left Fort Walton Beach. So 2 hours later would be 11 a.m. So this guy left 11 a.m. and he's headed north. He is a northbound bus. Now, if the buses traveled at the same rate, so that tells us the rate of the north is equal to the rate of the south in regards to their speed, right? If the buses travel at the same rate and were a total, this is their total distance apart, right? It is 352 kilometers at 2 p.m. So this is 2 p.m. for this guy and 2 p.m. for this guy, right? So that gives us their times. So we can create our own little chart based on this sketch that we have. So we have the, we have the rate and the time. We have the southbound bus. Now the southbound bus left at 9 a.m. and he traveled until 2 p.m. Okay. So from 9 until 2, that's 5 hours. I'm sorry. We don't know what the rate is. We know what the time is. That's 5 hours. The rate of the southbound bus is unknown. We just know it's the same as northbound bus, right? So the northbound bus, we don't know what their rate is either. We just know that this is going to be the same. But we know the time of the northbound bus. He left at 11, and at 2 is when we stop the clock. So 11 to 2, that's 3 hours. Now we know that the distance of the northbound train or bus, I don't know why I keep saying train, plus the distance of the southbound bus was equal to 352, because that's what it told us down here, 352. So we can write that as a problem right here. The distance of the north plus the distance of the south was equal to 352. Now we can split that into our rate times time. So the rate of the north times the time of the north plus the rate of the south times the time of the south is equal to 352. So now we're going to put in the information that we have from our chart. Now, the first thing I'm going to do before I do that, though, is I'm going to use this little bitty piece of information that I got over here where rate of the north and rate of the south are equal. And I am just going to change rate of the north to equal rate of the south. Now they're both equal because they have the same variable. That's going to help me a lot. So now when I rewrite this, I'm going to say the rate of the south times the time of the north, which is going to be 3 hours, plus the rate of the south times the time of the south, which is 5 hours, is equal to 352. And if I multiply these, RS times 3 plus RS times 5, then I get 3RS plus 5RS. And when I add them together, I get 8RS is equal to 352. If I divide both sides by 8, then I get that RS is equal to 44. So now that I know that the rate of the south is 44, and I also know that the rate of the north is the same as the rate of the south, I'm going to come in here and sub in 44 for all the variables that say rate of the south, which would be both of them, right? So if I put in 44 here and 44 here, I can find the distance of both by multiplying. 44 times 500 would be 220. And 44 times 3, I said 500, didn't I? 44 times 5 is 220. 44 times 3 is 132. And I'm going to double check by adding them together, and I get 352, which matches my total distance, which means I did my calculations correct. So the rate of both buses, which is what we were trying to find out, was 44 kilometers per hour. All right, let's try another one. All right, so here we have 94.2, and we're going to talk about trains this time. So we have a train that starts from Toledo. Let's say that this is the Toledo train. We'll put a little T right here in his window. And the Toledo train starts at 11 a.m. And he's going to head towards Mackinac. That's where he's going. All right, this is our Mackinac train. And Mackinac, the total distance here is 332 kilometers. So 332 from Toledo to Mackinac is 332 kilometers. So from here to here is 332. All right, at the same time that the Toledo train leaves, so at the same time, that means 11 a.m. We have a Mackinac train leaving as well. And he heads for Toledo, and he is traveling at 65 kilometers per hour. If they meet right here at 1 p.m., what is the rate of the Toledo train? So let's see if we can draw a table of this information. First of all, before we start our table, let's look at the picture and see if we can't understand what our equation is supposed to be. We see we have a total distance here. Let me use my highlighter. We have a total distance here. This line represents the total distance from Toledo to Mackinac, which we said right here was 332. So the Toledo to Mackinac distance is going to be equal to 332 kilometers. All right, that is our distance. So that means that if they meet in the middle, that this one drove a portion and this one drove a portion, and where they meet, it might not be halfway, but it is where they've cut that into two segments that when added together equals 332. So that means that the distance that the Toledo train drove plus the distance that the Mackinac train drove is 332 kilometers. So now we can break this down into our other equation, which is the rate of the Toledo times the time of the Toledo plus the rate of the Mackinac times the time of the Mackinac is equal to 332. Now that we have this equation, we can look at our chart. Let's do our table. So we have the rate and we have the time. We always have rate and time. The Toledo train. Let's look. Do we know what the rate of the Toledo train is? No, we have no clue. So we just put RT for the rate of the Toledo train. What about the Mackinac train? Do we have a rate? Yes, we do. They told us he was traveling 65. So we could put that in for the rate of the Mackinac train. Now, what about the time of the Toledo train? Do we have a time for that? Yes, we do. We have from 11 to 1 p.m. So from 11 to 1 p.m., that's 2 hours. And from 11 to 1 p.m. here, they have the same time. So that's 2 hours also. Right? They both left at 11 and they met at 1. So their time is the same. Excuse me, I have a little bit of a cold. So 2 hours and 2 hours. Right? So you can see we only have one variable that's missing, and that is the rate of speed for the Toledo train. So we can easily fill in our information. So I'm going to do that now. We don't know what the rate of the Toledo train is, but we know the time is 2. The Mackinac train, the rate was 65, and the time was 2. And that's 332. Now, 65 times 2, that's 130. And 2 times RT is just going to have to be what it is because we don't know anything more for this. Now we can subtract 130 from both sides. And 2 times RT is equal to 202. So if we divide both sides by 2, which we can pretty much do in our head, the rate of the Toledo train is 101 kilometers per hour. So this is not accurate, is it? Because if he's going faster, then he would have traveled further. So I didn't do my drawing very well, but it still illustrates the point, which is that they were unequal lengths of distance. So let's put that in for our rate of for the Toledo train, 101. And now we're going to do the math, right? 101 times 2 is equal to 202. And 65 times 2 is equal to 130. We add them together and we get 332, which is our original distance, which means that we did it correctly. All right, that is how you need to look at these types of problems. You're going to have some total distance from here to here, and there's going to be some point in which they start here or they meet here, and you have to figure out what distance 1 is and what distance 2 is based on information that fills in the blank. And it's always going to be D1 plus D2 is equal to some number. And then you're going to break this down into R1 T1 plus R2 T2. No Star Wars jokes, please. And you could sub in whatever subscriptive variable you want to represent, whether it's Toledo or Mackinac or Fort Walton Beach or whatever it is, northbound, southbound, and so on. Let's do one more just to kind of put this in our heads really well. This time, let's do boats. All right, let's do ships this time. Ships were 400 miles apart. So the total distance between here all the way over to here, this is 400 miles. All right, their total distance is 400 miles. And they're going to run into each other at some point because they are headed straight for one another. So at midnight, that's where they were, 400 miles apart. So this is 12 a.m. and this is 12 a.m. If they collided at 8 a.m., all right, this collision right here where they ran into one another. This is at 8 a.m. So that means the time for both is the same. So from 12 to 8, this is 8 hours and this is 8 hours. So we can go ahead and we can put in, here's our rate, here's our time. Let's call this boat A, or ship A, and ship B. So the rate of A, we don't know. The rate of B, we don't know. We know their time is the same. Because at 12 o'clock, midnight, they were 400 miles apart, and 8 hours later, they crashed into one another, and they were headed straight towards one another. All right, so now we'd figure out how fast they were both going. Excuse me. So it says, if one ship was 20 miles per hour faster than the other. So let's say that A was faster than B. We're just going to pretend we don't know. Let's say that A is plus 20 miles faster than B. So A is going to take B's rate. Let's say B plus 20. And then B is just B. All right, so A is going to be our faster boat. So that's what we're going to do. So now when we write this, we know that their distances, when added together, the distance this one traveled plus the distance this one traveled, was 400 miles. Because that's how far apart they were at midnight. So the distance of A plus the distance of B is equal to 400 miles. Now we know that the rate of A times the time of A plus the rate of B times the time of B is equal to 400 miles. Because rate times time equals distance, as we've been talking about. So now let's look at what we can drop in as our values. So we don't know the rate of A. We just know that the rate of A is B plus 20. He's 20 miles per hour faster. So that's what we're going to put in. We're going to put in B plus 20 for the rate of A. And the time of A is 8 hours. The rate of B, we don't know. It's just the rate of B. Actually, I should put the rate of B right there. So the rate of B plus 20, and then we have the rate of B. We don't know what B's time is. Now the time of B, we don't know what B's rate is. The time of B is 8, and that's 400. So now we can do some distribution. 8 times the rate of B would be 8 times the rate of B, obviously, and 8 times 20 would be 200. Is that right? No. That'd be 160 plus 160 plus 8 times the rate of B is equal to 400. So now we're going to get like terms together and we're going to subtract this so we can get all the variables on one side. So subtract 160 from both sides and add these two variables together. So it's 16 times the rate of B is equal to, that's going to be 0, and 40 minus 16 is going to be 24. So if I divide both sides by 16, let me roll this up just a little bit, then the rate of B is going to be equal to 15. Okay, so that means the rate of B is 15, and A is going to be B plus 15, or B plus 20, so 15 plus 20, that's going to be 35. Now we can find the distance that each one traveled. So I can say that 35 times 8, that's going to be, oh goodness, I can't do it in my head. Yes, I can. 8 times 30 is 240. 240, 8 times 5 is 40, so 240 plus 40 is 280. And 8 times 10 is 80. 8 times 5 is 40. 80 plus 40 is 120. So if I add those together, I should get 400. And I do. So the distance checks out, and we have the distances, we have the speeds, and we have the times for both boat A or ship A and ship B, and how fast they traveled before they had the massive collision that sunk them into the depths of the ocean. So look at these problems I've illustrated these sketches to try to trigger you into remembering what we're looking for. We're looking for two different distances added together that equals the same thing. And we're going to take those distances and break them down into their rate formula. All right? Keeping them on the same side of the equal sign. Okay? This is the picture we're looking at. This plus this. This is the total. It's two different parts that equal a whole. So we're always going to have that. We're always going to give you the total distance, and then you've got to figure out whatever missing information there is based on the other three parts that we give you. Now, sometimes one of those parts might be an expression. It might not necessarily be a number that you can calculate. But it will be something that will help you find your missing values that you can then calculate out and double check your work. Always double check your work. Whenever you can, like here, go ahead and figure out your distances. Add them together. Make sure it checks with the total distance you started with. If it doesn't, look at your calculations again. Something's off. Maybe you just dropped a zero, or maybe you didn't write it down correctly. I don't know. Double check your work and make sure you've got it all done. That's all we have for lesson 94, and I will see you in lesson 95.